Hello students, I am Josna Gawas, Assistant Professor in Botany at Government College of Arts, Science and Commerce, Sankli. In this session, I am going to discuss about anomalous secondary growth in stem of Dracena, a subtopic under Unit 3, that is secondary growth. In this presentation, I will discuss about anomalous secondary growth, reasons for deviation in the normal pattern of secondary growth, overview of primary anatomical structure of stem of Dracena, and anomalous secondary growth in Dracena stem. At the end of this module, you will be able to define anomalous secondary growth and describe anomalous secondary growth in Dracena stem. Anomalous secondary growth is defined as a deviation from the normal pattern of secondary growth. It results in the formation of secondary tissues and secondary vascular tissues. Anomaly in secondary growth could be due to any one of the following reasons: anomalous position of vascular cambium, abnormal behavior of normal cambium, successive cambium, included phloem, presence of medullary bundles, presence of cortical bundles, intraxillary phloem, secondary growth in monocots, or anomalous primary growth. Secondary growth is usually absent in monocots since vascular bundles are closed type. Closed means cambium is absent between primary xylem and primary phloem. However, few monocots like Dracena, Yucca show anomalous secondary growth. In Dracena stem, secondary anomalous growth is due to the formation of secondary thickening meristem, which I will be referring to as cambium. In transverse section of a young stem of Dracena shows outermost single layered epidermis covered with cuticle. Epidermis is followed by hypodermis, which is sclerenchymatous in nature, and in the center you will find the ground tissue with scattered vascular bundles. Vascular bundles are conjoined, collateral and closed type. Secondary anomalous growth in Dracena stem begins with the formation of a specialized meristematic layer outside the vascular bundles in the ground tissue. This newly formed meristematic layer functions as cambium. This cambium divides to form a multi-layer cambial ring initially. The activity of this cambial ring is abnormal. It produces parenchymatous tissue towards the outer side and partly vascular tissue and partly parenchymatous tissue towards the inner side. The vascular tissue gets transformed into vascular bundles which are amphivasal in nature. Amphivasal means phloem tissue will be surrounded by xylem tissue. The partially formed parenchymatous tissue towards the inner side gets lignified and gets transformed into conjunctive tissue. The cambium then produces parenchyma towards the inner side and pushes the first ring of secondary vascular bundles towards the center. After some time, the cambium again behaves abnormally, produces xylem in place of parenchyma and parenchyma in place of xylem. Consequently, another ring of vascular bundles is formed next to the cambial layer. These vascular bundles which are formed are alternating with the first ring of vascular bundle. The process repeats several times and many rings of secondary vascular bundles are formed. The last ring to be formed remains embedded in the lignified conjunctive tissue, and later cork cambium is developed in the hypodermal region, producing periderm as a protective layer. These are the list of references which I have used to prepare this module. Thank you for your attention.